Aguma Joshua from the Good Secondary School.
This meeting is being recorded.
So let's pray. Father, in the mighty name of Jesus, we want to thank you this afternoon that you have helped us to live and continue breathing on this planet. And so, Father, we surrender this discussion to your presence, that you shall allow your Holy Spirit to come and guide us, such that each and everything we shall discuss shall be of great importance to our future and in our studies. Through the mighty name of Jesus Christ, we have been able to pray.
Amen. Thank you very much for that wonderful prayer. Dear participants, I welcome you to our chemistry seminar. I have noticed some of you, we have a large number behind one Zoom account. You're welcome, may we all benefit. So this seminar, as I said, I chose that we discuss some of the questions that were done in the Waukesha mock exam. Those from districts which are not Wachiso might not have interacted with it, but those who study in schools in Wachiso should have seen it, though discussing it will also make our life good. So I want to welcome our first presenter, Joshua, to start sharing and take us through the first number. I don't know, has anyone succeeded in sharing the questions in the chat? I haven't checked. Okay, I see there is a no there. They'll be coming soon. Okay. Let's now start. Joshua, you can start sharing.
Yeah, good afternoon, people. So I
Good afternoon, Joshua.
I pray that you are getting me. So I want to start I want us to start with number 3. I'm Joshua Mlinzi. I'm in senior 4 at Ndare School in Barara. So I want us to discuss number 3 first. So now we are looking at number 3, which is basically about organic chemistry. They are telling us an organic compound X has the molecular formula of C2H4. And so when it comes to your head, if we are doing something concerning organic chemistry, the moment you see the formula, you have to first question yourself, is it an alkene, an alkane, or the like? So according to what we all know, that an alkane has the formula of CnH2. Then we know these are alkanes. Then an alkene has the formula of CnH2n. This becomes an alkene. Then an alkyne has a formula of CnH2n minus 2, which is an alkyne. I just want to start by giving for those raising hands, I'll allow you to give a question after the answer part I. So now let me first give us just a brief history about alkynes before we start. So organic chemistry, this is the basics of organic chemistry as we're starting organic chemistry, knowing these formulas. And so now I want us to go, and there are people raising their hands, but just allow me just a minute and I first explain this questions.
Joshua, you're protected. First discuss the number, then the answer, unless their issues are like they're not hearing. Okay. But if the audio is clear, please present. I can hear you well. Present, they'll make comments afterwards.
Okay, madam. And so we are looking at these. These are the basics of organic chemistry, which is what we call the homologous series. So an alkane is a homologous series. So now we want to look at 3AI. The question is asking, an organic compound X has a molecular formula of C2H4. Now, according to number 3, we'll see what suits this question. Now, let us continue. Write the name. It being an alkene and has, we know that one in organic chemistry, for a 1 carbon, we call it meth. Then 2 carbons are eth. Then 3 carbons prop. Then to this we add this. If it's an alkane, we add methane. If it's an alkene, we add ethene. So now, since this question 3, we are looking at C2H4. C2H4, it has 2 carbons, so it becomes eth. And since it is an alkene, because it succumbs to this formula, we call it ethene. So we are looking at ethene. So the name is ethene. That is the first answer of part I. Then when we are going to look at the structure formula. Now, according to the definition, we know the structure formula is the arrangement of atoms in a molecule. That's the definition of the structure formula. So now we are looking at CnH2n. They said this is the C2H4. They said it's our molecular formula. And we know the molecular formula is the formula that shows the composition of atoms. This molecular formula shows the composition, like what is contained, but does not necessarily show the arrangement. The difference between a molecular formula and a structure formula is the structure formula shows arrangement, which is not certain with the molecular formula. So now let us look at the way C2H4 is the molecule, the atoms are arranged in the compounds C2H4. Now, according to us, if at all we have had basics of organic chemistry, we know that it is since it is C2H4, alkenes, we know that they have a double bond between 2 carbons that it contains. Then we shall draw. These are the double bonds. The double bonds has a mast. Now, what with are 4 hydrogen atoms. And the 4 hydrogen atoms, we shall connect them like this. Because each carbon has to have 4 bonds. You know, carbon is like this. So carbon has 4 atoms. Carbon has 4 extra. Carbon uses 4 electrons to bond. That's why it is written like, if we're writing this carbon, it has to have 4 bonds attached to it. We have already written this bond and this bond. So we are left with 2 more. And so we fill them with hydrogen, making it hydrogen, and also come and fill it with hydrogen here and hydrogen here. And so this is our structure formula for ethene. The name is ethene, the structure formula is ethene. So that is number 3, part I. Now, let me go to part 2. I'll answer questions after I have explained. So now we are looking at B, part I. Compound X, the compound X now we have established is ethene. It is bubbled through bromine liquid. Write the structure of the compound. Compound X is bubbled structure of the compound. Now, I think because we have written the structure formula, they want us to write the structure of the compound X. I think the question here is looking at writing the structure of the compound formed after compound X was bubbled through bromine liquid. Because this question, it seems accomplished because I've written the structure in part AI. So part BI, it was an incomplete question because I think it wanted us to write down the structure of the compound formed after adding bromine liquid. Now, one thing we know is that when we look at we know we have saturated compounds and unsaturated. But according to what we know with some basics of organic chemistry, that is saturated organic compounds are alkanes. Then the rest are unsaturated. The rest we have alkenes and alkynes. Now, bromine liquid has a funny reaction with the unsaturated compounds. When bromine liquid is added to the unsaturated, the red bromine liquid turns colorless. That is the color change. And it is what we use to differentiate between the alkanes and the unsaturated compounds. When we have bromine liquid reacting with the ethene C2H4, we are going to form this. We are going to form a bromine. It's going to be a bromine, a carbon, a hydrogen, two hydrogens, and a carbon, a bromine again, and two hydrogens. But now, this is the formula, but the structure formula is what you're interested in. And normally these formulas, this tab, so it's better advised to use structure formulas. So now we're going to have bromine plus, let's write it in structure formula. The carbon, we say this is the structure formula, hydrogen, hydrogen. You can use molecular formula or structure formula. It all adds up to the same thing. Here, we are going to form a compound known 1,2-dibromoethane. So it's going carbon, carbon. So, but now here we are going to have a bromine and a bromine. Then we shall have a hydrogen attached, hydrogens attached. Now, notice that the bond that was here was divided by these two bromines. If you're to notice, you can actually do it like this. The bond that was here, that was making it a double bond here, was utilized here to form the bromine-bromine. So now, what they want is you to write the structure of the compound. Now, this is the structure of the compound that is formed. Let me write it clear form. It is a carbon, there is a bond, then there is a hydrogen bond, a hydrogen bond, a hydrogen bond, a hydrogen bond, then a bromine, a bromine. I don't have time to go into the naming, but this compound is called 1,2-dibromoethane. If at all some of you that have had this topic in detail, you'll find out that there is the IUPAC naming system, something like that, but we don't have time to go much into detail. But the name of this compound is 1,2-dibromoethane. It is a compound formed by mixing bromine liquid with ethene. Now, let us look at part 2, which is questioning what is the role. Part 2 is asking what is the role of bromine liquid in the experiment. Now, as I already told you, that bromine liquid is used as a confirmatory test to test if at all the substance formed is an unsaturated compound. If it is ethene, if it's not ethane, if it's not an alkane, it is used as X, compound X is an alkene. That is the purpose of bromine. Now, part 3, name one other compound that can be used instead of bromine liquid. One other compound that can be used instead of bromine liquid in the experiment. Now, in this experiment, we know that we are looking at just color change as a confirmatory test. So in this, we can also prefer to use potassium permanganate. I think many of us have interacted with potassium permanganate in diffusion tests, both in physics and in chemistry. In senior 1, when we are looking at diffusion and kinetic theory, something like that. So now, potassium permanganate is used similarly as permanganate when reacted bromine liquid. When the purple potassium permanganate will turn colorless. So the thing is purple to colorless. Meaning, one other thing we can use instead of bromine liquid is potassium permanganate. I think that is it. Unless there are questions, you can ask. Yeah, thanks for your time. Any questions?
Thank you very much, Arthur. That was Joshua. That was a very good presentation. Any
welcome.
comments from your colleagues? You raise your hand and then we'll allow you to talk. Okay. Seems like no one has any comment because that was a very good presentation. Before we go to another number, I want to inform those who have just joined or who were asking for the question paper. It was already shared. It has been shared in the group. Someone is asking in the chat, is bromine is alkaline or? Now, when we are using bromine liquid, bromine is a liquid it's a halogen. So we are not going to talk about whether it's alkaline or acidic. If the one which is acidic is bromine water, which has hydrogen on it, okay? But he has talked of bromine liquid, Br2, okay? Do we have any other question in the chat? Okay, thank you very much, Joshua. We'll get back to you after. Oh, someone is asking what is the meaning of unsaturated? Joshua, can you help with that? Hello. Okay, Joshua, for some reason, is not talking.
It's being unsaturated or saturated is that honestly, that I've forgotten it. I've never bothered really to find out. So I think the chair can help us out.
Okay. When we say something is saturated, it means it has enough of something and cannot take up more. As Joshua pointed out very well, carbon has to have 4 covalent bonds. So those compounds in which all the carbon atoms have got 4 covalent bonds, we say the carbon atoms are saturated. They have all their covalent bonds satisfied. But if you look at the ethene he has shown there, it is circled there. When you look at ethene, saturated means all the carbon atoms have single covalent bonds attached to them. That is 1 dash. Now, when you look at that ethene molecule there, you notice that the 2 carbon atoms each have 2 dashes leaving them, meaning they are unsaturated, okay? So if you can make them react so that those dashes go away and you remain with 1 dash between the carbons, you'll have made it saturated. So what you have to remember, like he said, alkanes, in them, all the carbons have just single covalent bonds. So alkanes are saturated. But when it comes to alkenes, there must be a double bond. That means it is unsaturated. And when you add to it hydrogen or a halogen, you can end up removing the double bond and you remain only with single covalent bonds. So compounds with only single covalent bonds, we refer to them as being saturated. Then those with double or triple covalent bonds are unsaturated. Okay, I don't know which other question I saw in the chat. Let me check my chat quickly. Emphasize the fact that when we are asked to name a compound, we give the name, not a formula. I think it was very clear. This is from Paul Lubura. Dear students, many times because we teachers, when we are giving you notes, we write the name and put the formula in brackets. But when you're going to sit your exams, be very careful. When they say name, okay, name the compound, give the name. Do not put the formula anywhere nearby. Then when they tell you give the formula, please give only the formula. Do not put the name anywhere in brackets. That is something that is taken very strictly in chemistry. When they ask you for them, give their name. When they ask you for the formula, give the formula. I actually want to caution you, do not use those formulae anywhere in your chemistry exam, except when you're writing equations or on questions where they have told you, write the formula of the compound. That is just a simple rule so that you don't get caught off guard. When you're describing something, let's say carbon dioxide reacts with this, write the words carbon dioxide, okay? From Jacqueline, I'm saying, when they ask for formula, do I write the structural formula? No. Usually when they ask for formula, we are writing the molecular formula. It is only when they are specific and ask you for the structural formula, which happens in organic chemistry. That is when we write the structural formula. For those who do not know what the structural formula is, it is that formula which shows how the atoms are arranged in the molecule. Like you see there for ethene, that is structural formula. Otherwise, we are always expected to write the molecular formula, which just shows the atoms which are present, that C2H4, okay? Sayuni Mwesigwa, you're saying you want me to repeat the role of bromine, okay? The bromine, as Joshua said, is supposed to confirm the presence of ethene, or if you want to be more specific, it confirms the presence of an unsaturated organic compound. Ethene is unsaturated. So that is how we test for it, because it is the only organic compound we test, the only unsaturated organic compound we test for in O-level. So that's why we can comfortably use the bromine liquid or sometimes bromine water. Okay, so the bromine is supposed to confirm the presence of the alkene. I see your chat has really been busy and I'm comfortable with the answers. Trevor, you asked, what do we observe when bromine has confirmed an alkane? I think what you mean, if an alkane is bubbled through bromine liquid, there will be no observable change. Or as someone said, the red liquid remains a red liquid. It doesn't change. But if it is an alkene or any other unsaturated hydrocarbon, we expect it, the red liquid should turn to colorless. Okay. So thank you very much, Joshua, for that presentation. I want to invite Emilia. You tell us the number you're sharing. Members, the question has been shared in the chat. The questions have been shared in the chat. So Emilia, you can start sharing. You tell us the number you're doing.
Okay. Good afternoon, everyone. I'm going to be sharing with you number 6 today. Kelvin, what could be the issue? Kelvin?
Kelvik, your hand is up. Could you ask what you want to ask?
Okay, since Kelvin has nothing to say, I will continue.
First wait, Emilia, there is teacher Amon who has a hand up. Yes, teacher Amon.
Okay, since there are no more hands up, I think I should continue. Is that okay, Teacher Eva? Okay, so question number 6, part A said, name 2 compounds that can be used to prepare sulfur dioxide in the laboratory. When we are preparing sulfur dioxide in the laboratory, we use sodium sulfite and dilute hydrochloric acid. This reaction is similar to that of carbon dioxide, where we are preparing carbon dioxide in the laboratory. The other way we can prepare sulfur dioxide in the laboratory is by using copper and concentrated sulfuric acid. Now, the question said name 2 compounds, and we know that a compound is a substance which consists of 2 or more elements which are chemically combined together. If we look at sodium sulfite here, sodium sulfite contains sodium, sulfur, and oxygen. Therefore, sodium sulfite qualifies as a compound. Dilute hydrochloric acid contains hydrogen and chlorine. Therefore, hydrochloric acid is also a compound. When we look at copper, copper does not have any element in it because copper itself is an element. So therefore, copper is not a compound. We also have concentrated sulfuric acid, which has hydrogen, sulfur, and oxygen. Our question said that we name 2 compounds. So in this case where we're having copper, I think that the above answer is wrong because copper is not a compound. Therefore, we are left with the option of sodium sulfite and dilute hydrochloric acid. Part B of this question went ahead to ask us to write the equation of the reaction that takes place when the mixture of the 2 compounds named in A above is heated. In this case, we are looking at dilute hydrochloric acid and sodium sulfite. When we heat dilute acid and sodium sulfite, we happen to have this equation take place. That means that 1 mole of sodium sulfite solid is reacting with 2 moles of aqueous hydrochloric acid to give 1 mole of water, which is a liquid, and 1 mole of sulfur dioxide gas, and 2 moles of sodium chloride, which is aqueous. When we are writing equations, we should note that when we are writing equations, we should always remember that is to say that the reactant or product is liquid, is a gas, aqueous, or a solid. We should also always remember to balance our equations so that you make sure that the number of sodium molecules on this side are equal to the ones on this side. In the chart, Pauline asked, can I use sodium sulfite and dilute sulfuric acid? Yes, Pauline, you can use sodium sulfite and dilute sulfuric acid. I'll continue to part C of this question, which asks us to state how the gas can be dried in the laboratory. This gas, which is sulfur dioxide, can be dried by passing it through sulfuric acid. Now we use sulfuric acid as a drying agent because, first of all, sulfuric acid is hygroscopic. For a substance to be hygroscopic, that means it absorbs water from the atmosphere. So concentrated sulfuric acid is used as a drying agent because of that property that it has. Then we also know that concentrated sulfuric acid only dries gases that it does not react with. If it can react with a gas, then it's not allowed we do not use it for drying, because instead of us getting the gas, we are going to get the salt that is formed when the concentrated sulfuric acid reacts with that gas. So in this case, sulfur dioxide, which is an acidic gas, does not react with the concentrated sulfuric acid. If we're looking at a case like ammonia, we would not use concentrated sulfuric acid to dry ammonia. That is because the concentrated sulfuric acid reacts with ammonia to produce ammonium sulfate. That was it about question 6. Any questions?
Thank you very much, Emilia, for that presentation. It was clear and precise. I'm calling upon participants. If you want to make a supplement or ask a question, raise your hand. Okay, someone is using the chat. Stena, is the acid used concentrated or raw? Emilia, would you like to handle that?
Yes, I would.
Mhm.
In this case, we've seen two acids. At the start of the question, they asked us for the reactants used to, the compounds that are used to prepare sulfur dioxide. When we are preparing sulfur dioxide with the salt sodium sulfite, the acid used is dilute. When we are preparing sulfur dioxide with copper, we are using concentrated sulfuric acid. That is because copper does not react with dilute acids. Then finally, at the end of the question, we used concentrated sulfuric acid to dry the sulfur dioxide.
Okay.
Where
Thank you. Yeah.
can we use dilute hydrochloric acid?
No, before you move on, Emilia, I want to make a comment about the acid. Preparation of sulfur dioxide is one case where we have a variety of substances that can be used. The conditions for the acid are given different depending on the books. If you read your Atkinson, it talks about using concentrated sulfuric acid with sodium sulfite. So if you mention that, it will also work. If you talk of using the dilute acid with the sodium sulfite, you'll also be correct because it appears in one of the textbooks that you use, that is Companion Chemistry by Arthur Ndagije. Your Lambert seems to talk of only the one where there is copper and concentrated sulfuric acid. Okay, I hope that answers about the acid. So feel free, but make sure you mention the condition, whether the acid is concentrated. Don't ignore it. Okay. I am not seeing the other questions. I want to check something else in the chat. There is a number of things happening in the chat which I want to check. Are there any other drying agents that can be used to dry the sulfur dioxide? Yes. The other most common drying agent is anhydrous calcium chloride, and it can work. You just know, as Emilia said, as long as the gas does not react with the drying agent, then it can work. There is another question I have just seen. Yes, are there, first of all, I want to talk about the one who posted TK, I see TK. Are there any other drying agents that can be used to dry SO2? My dear candidates, I have just said, do not write those formulae when in a sentence. So that would make you miss that mark. Write the full word, sulfur dioxide. So I see Claire, can we also use dilute sulfuric acid instead of hydrochloric acid? You wrote the words. That is very correct. Okay, I think we've answered those questions. There were issues with the drying agent and also issues with the concentration of the acid. There's that bit of, is the gas basic or acidic? The gas being made is sulfur dioxide. If you go back to types of oxides, sulfur dioxide is an acidic oxide, or what we call an acid anhydride. Okay, an acid anhydride is a gas. When you add to it water, you make a certain acid. So when you add water to sulfur dioxide, you make an acid called sulfurous acid. That is why we look at sulfur dioxide as an acidic oxide, which is sometimes called an acid anhydride. Then God's chosen, you asked, how can you know the gas reacts with a drying agent? Read your notes. Those comments are usually mentioned, especially ammonia. It is one gas which is not dried with the common drying agents because it reacts with them. And when I talk of common drying agents, I am talking about concentrated sulfuric acid and anhydrous calcium chloride. Those are the two common drying agents. Ammonia reacts with them, and any textbook or all your notes should mention that. That is why we instead dry ammonia using calcium oxide. Okay. I hope that answers all the questions. I'm checking through the chat. That is it. Okay, Atai. Atai, your hand is up. You can unmute and then answer. Oh, you don't have a microphone, Atai. Please chat. Post something in the chat, okay? How many drying agents do we have? Oh, good. Go and read your chemistry, but I repeat, the most commonly used are concentrated sulfuric acid and which is a liquid. When you use concentrated sulfuric acid, it's usually contained in a wash bottle. And then the other one, which is common, is anhydrous calcium chloride, which is usually a solid. Because it's anhydrous, it's always a solid. So for it, it's usually put in an apparatus we call a U-tube. And then the gas goes through the U-tube and is dried by it. The other drying agent is calcium oxide, which is used ammonia gas. So my dears, I hope I've answered all the questions. Atai, Gloria, I'm waiting for your question in the chat because you do not seem to have a microphone. Could you post your question in the chat and we answer it? Someone is saying, why is heat involved? I don't know where you're saying. Why is heat involved in the reaction? Usually there are some reactions when you mix the reactants, they don't react in the cold. But when you heat them, it speeds up the reaction and you start seeing it happening. So that is why that condition happens for certain reactions. And we mentioned that after mixing the reactants, heat. Those which don't need heating, we just say the reaction can take place at room temperature. Okay? Okay. Thank you very much, Emilia. We are going to go to the next question. DJ, you wanted, you have funny names, people. DJ Kelvic, you wanted to share the screen. Emilia has just stopped sharing the screen. Another person whose hand is up is ITLP36. But again, you don't have a microphone. So could you post your question in the chat?
Teacher Eva.
Yes, please.
So is there a way we could help these people to connect to audio? Because I think that's their problem. They cannot hear us.
Now they can't even hear us telling them to enter with audio. If that is the problem. So can you type something for them? that Gloria, Atai, and Itel, please select the option of enter with audio. Then you will hear and also talk, okay? There's a post here. Yes, we know that ammonia is basic. So can't it be dried by a concentrated acid to dry it? I think you're repeating what we have said, that ammonia reacts with the concentrated sulfuric acid, so it cannot be dried by it. In the same spirit, ammonia reacts with anhydrous calcium chloride, so it cannot be dried by it. Thank you, my dears. I want us to do as many questions as possible. So I don't know if Joshua is still around. You take us through the next number. Emilia, thank you very much. Oh, sorry, maybe before Joshua starts, we could have had some other participants coming in who would like to share some other number. Can you raise your hand apart from Atai and Itel? Oh, Itel, your microphone is on. That is really good. Can you ask your question? If it was a question, Itel P36. Itel, unmute and ask. Yes, Itel. Until you close the microphone. Okay. Atai, please do what Itel did and enter with Emilia. Type something for those people, an instruction. Do we have another person ready to share a number before I go back to our two presenters, Emilia and Joshua? I want to give an opportunity to someone else. Okay, Dalton. Dalton, tell us which number you're ready to share before I go back to the two who have presented already.
Number 11.
Okay. Emilia and Emilia and Joshua, you first wait. Let's hear another voice. So Dalton, let me give you rights. You share number 11. Raise your hand, Dalton. Over to you, Dalton. Dalton, you now have rights. You can unmute and start sharing even.
Good afternoon, everyone. I'm Dalton and I'm going to share with you number 11. I guess everyone is hearing. So that's our question number 11. Beginning with part A. When hard water is treated with soap, scum is formed. State the chemical names for soap and Roman numeral 2, scum. So we should all be aware that hard water is this kind of water that once reacted with soap, it does not easily form leather. So, and another thing I should remind you about it is the manufacture of soap. We should be aware that soap is manufactured by the process called saponification. And in this process, we boiled concentrated sodium hydroxide with vegetable oil. We should be aware that vegetable oil is obtained from from simsim, talk of the groundnuts and sort of. So once these two are boiled,
Mhm.
after some time we should allow them to cool. Then after the cooling, we shall have to add in we should add in the sodium chloride, which is the blend of which the purpose of the sodium chloride is precipitate the soap, and apart from precipitating the soap, it's salting out. So that's another okay, like that's another name for precipitation. The purpose of the sodium chloride salting out the soap. So after that, the soap will have to float on top of the solution. Then other processes will have to follow. So going to our question number 11, state the chemical names for soap. So the chemical name of soap will be sodium stearate or potassium stearate. We should be aware of the definition of soap, that soap is a potassium or sodium salt with a long hydrocarbon tail or with a long hydrocarbon tail and
Hello.
yes.
Dalton, I want to just give some little guidance to you all, my dear presenters. When the question is set, please go straight to answering. Don't teach, because all of us are candidates. We are ready to write the exams, right? So
Okay,
just give the correct answer so that people know the correct answer that they should put, okay?
Okay, thank you,
When
madam.
they don't understand, they'll ask and you explain.
Okay.
Okay, so could you repeat now very well part A? When you're asked to state the chemical name for soap, what do you put?
So the chemical names of soap will be sodium stearate or potassium stearate. These could be the spellings. I hope you can see them. Then our Roman numeral 2, they're asking, state the chemical name for scum. Scum will be calcium stearate or magnesium stearate. And then Roman numeral 2, they're asking, part B, they're asking, identify two ions that lead to the formation of scum when soap is clean. Fabric. We should be aware that the meaning of fabric is something like a cloth. So identify two ions that lead to the formation of scum when soap is clean. Fabric. So we shall have the calcium ions and the stearate ions, or we can still have the magnesium ions from the hard water and the stearate ions from soap. Write equation of the reaction leading to the formation of scum. So this is our equation. We are question 11, part B, Roman numeral 2, that's our equation.
Okay, thank you, Dalton. I have gotten a complaint. Someone else had also asked for the same question. So since you've done part A and B, let her do the remaining parts, okay? But thank you for that. But when questions come, the two of you should handle them, okay? So can we have part C and D? Thank you very much. As the other person prepares, Gloria, now your hand is up properly with a microphone. Please lower it if you have nothing to say. Gloria, if you have something to say, ask now that you can talk. Okay, you have nothing, please lower your hand or I'll lower it myself.
Okay, I'll continue from where Dalton stopped with number 11. Part I said identify one compound that can be used to break the hardness in water. One compound that can be used to break the hardness in water is permitite. And then it said write an equation to show how the compound named in CI breaks down the hardness in water. Here we are writing an equation of calcium sulfate, which is aqueous, reacting with sodium, and we're using letter Y to represent the permitite. And that is in aqueous, so you get calcium on the permitite plus sodium sulfate. We then went to part D that said, describe the cleaning action of soap on fabric stained with grease. So here we are having soap molecules, as we can see in our paste. As we can see in the diagram, we are having the dirt that has been highlighted, the soap solution, and the dirty cloth. Now, a soap molecule has a head and a tail, and they're telling us that the tail, which is nonpolar in this case, dissolves in the oily dirt, while the head dissolves in the water. So from that, we are having that as this soap, as the soap molecule tails dissolving in the oily dirt, they are removing the oil from the cloth. When you shake this solution, you happen to have that now the dirt moves away from the cloth and it's washed away by the water. So in this case, our answer is that when soap is added to a fabric stained with water and grease, in water, the polar end of the soap dissolves in water, and the non-polar organic end of the soap, which we saw as our tail, dissolves in the polar stain on the fabric. Agitation. Agitation is to shake. So agitation causes the dirt to dislodge from the cloth and pass into tiny droplets. The tiny droplets are washed away by clean water. Part E then says, state one advantage of using hard water. Yeah, I have hard water contains calcium ions used for the formation of animal teeth, bones, and shells. There are also other advantages of hard, like hard water is good for beer brewing. Hard water also tastes good. Then have part E2, which says state one disadvantage of using hard water. We have that hard water washes soap since it requires much soap. When you're washing with hard water, use a lot of soap, wash with soft water, because first the soap is going to form a precipitate, scum and everything. And by the time it finishes that, to start forming lather, you've used enough soap. Then hard water forms a boiler scale inside the tube, which may block tubes. I have an image of a boiler scale here. If we look at this tube here, we're having this white part as the boiler scale. So if every time hard water is passing through, it continues to form that boiler scale, we realize that now the remaining part from the original pipe is small. So eventually the tubes will block. Then finally, we have that with hard water, soap forms scum, which makes washing difficult as it makes dirty marks on the cords. That was it with number 11. And I think we can proceed with the questions.
Thank you, Emilia. We'll take up the question, though I had some supplements to make, I think. But let me first see the questions. Okay, let me first make my supplements. In the process, I might have answered the questions. Can you go back to where we had to write one, name a compound that can be used? Hi, Gloria, you got a microphone. Now you've become a problem to us. Could you mute? Thank you. Okay, when they told us to identify one compound, apart from permutate, you can use sodium carbonate. Okay, we can use sodium carbonate. And then when they ask us for the equation, it will be similar to what Emilia gave us there, except that we shall replace the Y with the formula for carbonate, which is capital C, capital O, and a 3. So the equation will be the same. Okay, so you can use carbonate, the sodium carbonate, to remove hardness of water, or you can use permutate. That one can work as an alternative. When you're writing the symbol for permutate, you're not tied to using letter Y as Emilia has done here. Some books use letter X. I've seen others using letter R. But make sure the letter you use is not of a symbol in the periodic table. It's not a symbol of an element in a periodic table. So the letters Y and X are very comfortable. So don't wake up and say, for me, I've given permutate symbol C. For us as chemists, capital C is carbon. So we can comfortably use Y and X. So that's the comment I can write on, I can give on that question. Then could you go to the one of who talked about removing hardness of water? Oh yes, the question as it is there. Identify one compound that can be used to break the hardness in water. Unfortunately, this question had a very big technical error. We do not break hardness in water. Can someone tell us what do we do to the hardness in water? What is the correct term that we should be using? You raise your hand and then I'll select you. Anyone who knows the correct chemistry? We don't break hardness in water. What do we do to the hardness? Yes, Namco. You can unmute.
We
Yes,
just
pardon?
we don't break down.
Please repeat the first part you were breaking.
We don't break, we just remove.
Very good. The correct chemistry is we remove the hardness of the water. And when we remove that hardness, we make the water soft. So although this paper came with that technical mistake, please do not write that you have broken the hardness of water. It won't be marked right. You should mention removing hardness of water. Thank you very much. Then continue to the next slide, Emilia. I make another comment which I want us all to share. Yes, no. Before, I think I want an earlier part where we had to mention advantages of hard water and disadvantages. I think that was E. Yes. The question is telling you state one advantage of hard water. For the sake of the seminar, you are free to give all the advantages of hard water that you know. But if you're writing the exam, when they tell you to state one thing, please stick to only one thing, okay? If you write excess, it's okay if all the excesses are correct. But those excesses, if any of them is wrong, it makes you miss your correct answer. So I want us to get used, if they tell you name two compounds, let it be names and let them be only two. Even if in class you know 5. Even if you write 5, no one is going to give you extra marks. So let's get used to following the instructions. Those are the comments I think I wanted to make. Now I'll take on others. So I hope I've answered many of the queries that would have come through the chat. I still see some hands up. Namco, if you still have a question, you leave your hand up, even ITIL. Otherwise, we lower. When they ask for formula. The advantage, I see an added advantage that hard water reduces lead poisoning. Yes, that is a very good advantage. That boiler scale you saw in the image, as that coating forms, it prevents the lead in the pipes from reacting with water. So that is one good thing of the hard water. Okay, and Nokia 30, your hand is up. Would you ask your question? Nokia 30. I have asked you to unmute. Please unmute. Press your microphone and unmute. Okay, Nokia is failing to handle the machine. We'll go to someone else. Any other questions that we haven't handled as I move to another presenter? Emilia, can you read out the questions in the chat for me to answer?
What is the meaning of polar?
So what do we mean by polar? Those are the things which are charged. They have the ions. When we look at ions, they are charged. So those are the ones we refer to as being polar. I think it is Dalton is annual presented and went through the preparation of a salt, of a soap, showing you use an alkali and then a vegetable oil. So that alkali has got sodium ions. That part is charged, and so that is the polar part. Then the vegetable oil gives you the stearate part. Stearate is an organic part with carbon, about 17 carbon atoms and about 35 hydrogen atoms. That part does not have the charge. So much of it is therefore referred to as being non-polar. So you will not be required to mention what polar means or non-polar, but you can use the term. If you're not comfortable with polar and non-polar, you can use the terms hydrophilic. Philic means loving. The hydrophilic heads, those are the ones which go to the water. Then the hydrophobic, when you have a phobia, you fear something. The hydrophobic tails, they are the ones which attach in the dirt. Okay, so you can use the terms you use and you're comfortable with, and you'll be good to go. Okay. What others do we have? Someone is saying how soaps cleans a dirt. They want to go back to how soap cleans a dirt. Was it network that disturbed you? Emilia, can you do that one very quickly and we'll move on? But I'm asking you, when she explains and you understand, now take time to go and read it in your book. She is not here to give out notes, okay? But Emily, can you start sharing so that we see that part? But as you share, there's the question, when removing hardness, what do we precipitate out? The calcium carbonate or sodium sulfate? Unfortunately, I don't see the full name of this question, the one asking this question. All sodium salts are soluble in water, so they cannot form precipitates. So the precipitates that will form are either calcium carbonate, if the salt if the hardness was caused by calcium ions, or magnesium carbonate if the hardness was caused by magnesium ions. Okay, so Emilia, go first to the explanation, then do that quickly as Joshua prepares his next presentation. Yes, Emilia.
Okay, I said that when you're describing the cleansing action of soap or the cleaning action of soap, we're going to talk about the nonpolar tails going to the grease that is in the cloth and the polar ends remaining in water. Our next image, I said, showed us when most of the tails, the soap tails, had anchored into the grease, and when you shake the water, this grease moves away from the cloth with the water molecules. Since now the heads are in the water, are in the water. So when you shake, the entire head, tail, and this combination moves into the water and forms tiny droplets of that. And then I say that finally, when you're writing your answer, you'll say, when soap is added to a fabric stained with grease and water, the polar end of soap dissolves in water, and the non-polar end of soap dissolves in the non-polar grease stain on the fabric. Agitation, which we said is shaking, causes the dirt to dislodge from the cloth and disperse into tiny droplets. The tiny droplets are washed away by clean water. That was it about the cleaning action of soap.
Okay. Someone was asking, is there any other way of describing the cleaning action of water? Yes, you don't have to use the words she uses, but what is important, you must mention that the soap has two parts, a head, which is water loving, and a tail, which is water hating. And we said for water loving, you can use hydrophilic or polar. Then after mentioning those, mention how the soap arranges itself in relation to the dirt. We say the tails enter in the dirt and the heads remain in the water. That's another point that is important. You must therefore mention shaking. When we use soap, we shake, or agitate, I shall say. When we shake, that is when the particle now surrounded by the soap molecule gets off the cloth. And so all those steps must be mentioned, but you can say them in your own words. There is no way of dodging that. As Joshua prepares to come on, Trevor, you asked a question in the chat. Are we allowed to add equations when describing? Yes, you can add equations, but they will not be given marks. When we are describing, we are narrating the story. And so we do not have to write equation unless they have said, describe and write equation. Okay. However, whenever you are told to explain anything in chemistry, when you're explaining a chemical change, you are going to tell the story that this one reacts with this and they produce such and such. You must put an equation. So if you know the correct balanced equation, always add it there whenever you're explaining, because sometimes they do not tell you that write also equation, but the moment the question is explained, please endeavor to put the equation, okay? Yeah, that last two questions, oh God, am I saying? Okay, Joshua, you can get on. Write equation for the reaction of soap and hard water. I thought that was given by Dalton at the beginning. I think you're making us move around a lot. Okay, so can we have Dalton get ready? Don't worry, this Okay, maybe Dalton's bit could have been whatever, small, and you didn't enlarge it. Emilia, do you have the equation for the reaction between soap and hard water? We show that quickly, then Dalton presents. I'm sorry to disturb you, but I'm seeing these questions in the chat. I hope it will be big enough. Okay, yes, we have that one down there. I'll talk about it. We said soap contains usually calcium ions or magnesium ions. That's what we have there. So if the soap, the water, sorry, it's hard water contains either calcium ions or magnesium ions, while soap must be containing stearate ions. So if you look at that reaction, the calcium ions are reacting with stearate ions to form calcium stearate. And that calcium stearate is the solid called scum. That is why it appears actually as a precipitate, okay? So I hope that answers all your questions, my dear. We'll share with you those answers. My presenters will give me the answers and we'll share them with you in your groups, okay? Joshua, you are the one presenting. So let's go to another question.
Yeah,
and after that, thank you.
So I think presenting next.
Yes.
I hope I'm clear.
Very loud and clear.
Let me continue with the number. So now we are going to number 4. I think I shared number 3. Now we're going to number 4, which is basically mole concept. So as the teacher said, I have to be precise. I won't go much into explaining a lot, but I'll be precise to the point. So now we are looking at number 4, part AI, but we begin with reading the question such that in mole concept, once you misunderstand the question, it is the start of everything. So you have to give it enough time. So now let us start with understanding the question. When strongly heated magnesium reborn was treated with dry nitrogen gas, solid. So we know that when magnesium reacts with nitrogen to form a solids that react with magnesium directly. So when magnesium reacts with nitrogen, we know we're going to form magnesium nitride. Magnesium has a valence of 2 and the nitride has a valence of 3. So you're going to form magnesium nitride, which is in this formula. So now we have formed magnesium nitride with magnesium. So now, if we are to continue, AI is asking, determine the empirical formula of solid W given that 0.72 grams of magnesium for this 1 gram of solid W. Now, what you know is that the magnesium has entirely combined with the nitrogen to form this solid magnesium nitride. Now, excuse me, Teacher Eva. Excuse me, teacher. Teacher. Okay, if the teacher is not speaking, let me try to explain this.
Yes, yes.
What you know is that
sorry, I'm sorry.
Joshua,
I'm here. Yes, you had a question.
So the teacher was saying that if you could give me, I was requesting for a minute just to do some emergency, a minute or two, then I get back.
Okay. While you're at it, I'll make a comment.
Emergency has popped up, a minute or two, then I get back.
Okay, fine.
Okay, teacher.
But you can leave what you're sharing so that I first talk about it. Okay, can we all turn to question number Emilia, can you share question number 4 and we proceed? Now, when you're told to, you're given information about an empirical formula. Although Joshua started by first identifying the compound, that is not, it's time wasting. You can go direct and calculate the empirical formula using the information that you have been given. And that is what is expected of you in the question, okay? So let's look at the information given. We have magnesium. Okay, we have when strongly heated magnesium ribbon was treated with dry nitrogen gas, that is what was formed. They are telling us to determine the empirical formula of solid W. Okay, if we are going to determine the empirical formula, the first thing is to identify the elements present. Can we identify which elements are present in this compound W? We are going to talk and share so that you answer as we move on. Okay. You raise your hand if, oh, you want to write in the chat maybe. Can we raise our hands, those who want to say? The story is there. When strongly heated magnesium ribbon was treated with dry nitrogen gas, solid W was formed. You're going to determine the empirical formula of solid W. So before you start, can we identify the elements? Yes, Claire, thank you very much. The elements are magnesium and nitrogen. Yes, Joshua, I see you're getting ready. Let me first make this point. So the elements are magnesium and nitrogen. Thank you, Dennis and Claire. Once you have identified the elements, you must be able to determine the masses or percentages of those elements in the compound formed. Now, if you look at it, they told you that when they heated 0.72 grams of magnesium, they made 1 gram of solid W, which means in that W, the magnesium is equal to 0.72. So if the magnesium is 0.72 grams, the question is, what is the mass of the nitrogen? Okay, so when you press your calculators, what is the mass of the nitrogen that you're getting? We should be subtracting 0.72 from 1. Very good, Dennis, you're giving us 0.8. So that is where we start our empirical formula from. You have identified the elements and now you know the masses of each, so you can proceed. Joshua, I see you are back, so you can proceed from there. Hello, Joshua, are you still there? I saw your hand up. Okay, if Joshua is not yet ready, we can proceed.
Oh,
Okay, yes.
teacher, I'm back. And so I think the teacher has helped me give her the basics of the question, and she has introduced the question. So mine is just basically left with calculating. And so as I was earlier saying, that she has already described to you the magnesium and the nitrogen. And so I'll still bring it in that if you have, they are giving us a certain mass of magnesium and we are combining it with a particular mass of nitrogen, and we are coming up with a solid which is 1 gram, meaning we have combined these two masses and have come up with a total mass of 1 gram. But of which, of this 1 gram, remember we combined magnesium, which is a mass of 0.72 grams, then plus a particular mass X of nitrogen to form 1 gram of this solid, which has magnesium and nitrogen. So now this 1 gram consists of 0.72 grams of magnesium, but we will know that if we subtract 1 minus 0.72, we are going to get, as you had calculated earlier, 0.28. Now this is the nitrogen in the compound, this is the mass of nitrogen in the compound, and this is the mass of magnesium in the compound. Yeah, so that is basically when we are starting the calculation. To start calculating empirical formula, we need to know the composition of the various substances. But now we know the composition of magnesium is 0.72, and we know the composition of nitrogen is 0.28. So now the composition. So now, next in calculating empirical formula is, remember when you're doing empirical formula, this is what you start with. You start with, write the word composition and write the composition. So according to our element, remember our element is magnesium nitride. So in magnesium nitride, we know that it is going to contain magnesium and nitrogen. So we write the composition is magnesium and nitrogen. But now what do we know? We know that magnesium is 0.72, and from our calculation, nitrogen is 0.28. So now we're done with composition. Now next, we are going to calculate moles. Because now I've started, this is the calculation for empirical formula. This is the order of the way you do the work. So now we're going to the moles. Now, moles are gotten by dividing the composition by the relative atomic number of that substance. And we know that magnesium, the relative atomic mass of magnesium, we know it is basically, it was given here, it is 24. They are normally given in the question. So now it has been given to us as 24. 24 is the relative atomic mass of magnesium. So we're going to write here, we're going to divide by 24 to get the moles contained. And nitrogen, it is 14. So we divide this composition by 14. Now in dividing, I think you're also dividing with me. We divide 0.72 by 24. We're going to get our answer as 0.03. And our moles, the moles of nitrogen present are 0.28 divided by 14 to give us our answer as 0.02. Now these are the moles. So we go to the next thing, which is simplest ratio. Now the simplest ratio is normally what gives us the empirical formula. So if we go to simplest ratio, as you know, ratio is literally part, it's like a fraction. A ratio is a fraction. So we are going to look at 0.03. We are going to divide this by the smallest. And according to what you know here, the smallest is 0.02. These symbols show that it's a ratio. And this one would be 0.02, since 0.02 is the smallest. So when we divide 0.03 by 0.02, get our answers 1.5, and we get here answers 1. Now, since we have a 0.5, we are going to multiply by 2 to get 3 and 3 to 2, meaning us empirical formula would be, write the magnesium, the elements. Now magnesium, since it's in this line, is represented by 3, and the nitrogen is represented by a 2. So this gives us the empirical formula, Mg. Writing equation for the reaction between magnesium and nitrogen. But we already know that magnesium, which is a solid, is going to react with nitrogen gas to form magnesium nitride. Since I already know the formula, but these are the keys. When you're writing a formula, you have to know the valences. It is what is key. So
Have we lost Joshua? I can't hear you. Okay, seems Joshua went off due to network. Now what do we do? But he had taken us some distance. Sorry, my laptop doesn't, okay. I think I can now share on his behalf. Okay, let me try to share. I hope my laptop can allow me to write. So he had done part of what we had to do. So he had given us the elements. We said the elements we started with, we had magnesium and nitrogen. You'll remind me. Then we had masses. The mass of magnesium was 0.72 and the mass of nitrogen was 0.28. Someone in the chat, I think who seemed to have entered late, was wondering how we got the mass of nitrogen. If you look at that question, they said somewhere in the STEM that when 0.72 grams of magnesium was heated, they managed to form solid W, which had a mass of 1 gram, okay? And the question is, we have already identified that the two elements in solid W are the element magnesium and the element nitrogen. So if 0.72 is magnesium, then the remaining mass must be nitrogen. So to answer your question, we got the mass of nitrogen by subtracting the 0.72, which is the mass of magnesium, from 1, which is the whole mass of solid W. Okay, so I hope that helps a bit. Okay, so I'll continue. So he had given us the masses, then now we were getting the number of moles. Number of moles, sorry, this technology, you people are more comfortable with it. Okay, the number of moles, he had gotten them by dividing 0.72. And please, I encourage you, each of these steps as you're working out, write them. You make sure you write the step, number of moles, and then you show what you're working out. So we have 0.72 divided by 24, as he has shown us, because the 24 is the mass of 1 mole of magnesium. So if we want to find out the moles in 0.72, we divide like that. Then on the other side, we have to get the number of moles, it's 0.28 divided by the mass of nitrogen, which was given in the question as 14. I think that is where he let us off. What values do we get from 0.72 divided by 24? Okay, I'm seeing in the chat. So we are getting, yes, people are giving me 0.03. So that is the mass we are getting, 0.03. 0.03, then 0.28 divided by 14. We are getting 0.02. So when we go ahead and divide, so now those are the number of moles. Please indicate them properly and do not dare show when you're canceling. Some of you, because you're dividing, you cancel in the numbers. That spoils your answer. So leave this statement intact for someone marking you to see very well, and also this answer. Then we now go ahead and therefore get the mole ratio. I think that is where we were at. Now to get the mole ratio, we know we divide by the smallest. So we shall have our 0.03. The smaller one of these two figures seems to be 0.02. We divide it by 0.02. And then this side also we divide 0.0302 divide by 0.02. When we press our calculator, this side I expect us to get 1. What do we get on the other side? Okay, unfortunately, I'm the one sharing. Can I have one of the co-hosts sharing with us the answers you're reading there? We had Dalton, you're a co-host. Can you check from the chat and share the answers? Okay, we're getting 1. Yes, I'm seeing people have posted 1.5. So
Teacher
here we get,
Eva,
yes, please.
Teacher Joshua is back.
Oh, okay. Let's finish this. So we have 1.5 and 1. Okay. Now, 1.5 cannot be perceived as a simple ratio. Okay. When we say ratio, they must be whole numbers. So we make it a point to therefore change it to a whole number. And one thing I want to emphasize, if you're changing something which ends in 0.5, you're going to multiply it by 2. So in this case, we shall go ahead and multiply these two, this side by 2, and also this side by 2. So our answer this side will be 3, and the answer this side will be 2. Are we following? Now that is not the final answer. It is just the mole ratio. So we shall therefore conclude that the empirical formula, we now write the correct symbols. We have magnesium and nitrogen. And for each of them, we write the number of moles that we have got. Under magnesium, we got 3. So we shall put a 3 there. Under nitrogen, we got 2. So we shall put 2 there. And this is our final answer. Okay, so that is how we work it out. You will have done some questions in your school where the question, so that this part here is what is required, what is required for that question. But I'll caution you, sometimes this one of these ratios ends in 0.3. If it ends in 0.3, you will multiply both sides by 3. Okay, in order to remove that decimal place. The most common are those ending in 0.5 and those ending in 0.3. So if it ends in 0.3, you multiply both sides by 3. If it ends in 0.5, we multiply both sides by 2. Okay, so I'll now hand back to Joshua. Joshua, you can continue and finish the next part of the question. I'll first stop sharing. Over to you, Joshua. Where is Joshua? Could you raise your hand? Or has he gone?
Teacher, I would request that you make me a co-host again, then I share my
Oh,
screen.
sorry, I hadn't noticed you had lost the co-host rights. Okay. So you can continue.
I'm sorry there was a network problem there, but I hope I would go on smoothly. So let me get to my work and I share the screen. So we're still looking at number 4. I'm glad that she has taken me through part A and I. Yeah, she has explained a lot. I was trying not to explain, follow the instructions. So I was still on this part where we're doing the equation, part A, Roman 2. So we have a magnesium reacting with nitrogen, and we know that we follow the valences. And so magnesium has having a valence of 2 and nitrogen a valence of 3. They are going to exchange valences and come up with magnesium nitride, which is in this formula. It is a formula of magnesium. This is the formula of magnesium nitride. Then it's a solid. So this is the equation. Now we are going to part BI, which is asking us when solid W, remember we have established solid W is magnesium nitride. So when solid W reacted with water, produced gas Y and solid X. State how the gaseous product in B can be identified in the laboratory. Now, at the back of our minds, we know that when we react magnesium nitride with water, we are going to form, you don't have to write this equation, but you have to have it at the back of your mind, that you're going to form magnesium hydroxide and ammonia gas. So this is what you have to have at the back of your mind. So now, magnesium hydroxide is a solid. So this is what has to be at the back of your mind. So now they're telling us that when can be identified in the laboratory. But remember our gaseous product is ammonia. So ammonia being our gaseous product, we know that the tests for ammonia. First of all, ammonia is the only alkaline gas that we know. Now, minus ammonia being the alkaline, there are also other tests for ammonia that it's the only gas that reacts with HCl, hydrogen peroxide. Also, it has a unique smell. It is the smell that smells like rotten eggs. So all those can be tests for ammonia gas. Now, they are telling us to identify the solid X. The solid X form was magnesium hydroxide, because the equation is giving us magnesium hydroxide and ammonia gas. So basically, those are the tests for active teacher, because don't make number.
Okay, thank you very much, Joshua. Does that mark the end of the... Yes, please.
Any questions?
Can we have people who want to make questions or comments raise your hands? I think we can listen to some voices.
They are there, I can take them.
Raise your hand if you have a comment. Yes, I see. The hand has gone down. Okay, I've asked you to unmute. Martin, please unmute and make your comment.
Yes, thank you very much. In the work of the Madame Moles, I want to know if you make one equal sign from the left hand side, whether it is not enough.
Could you be clear by one equal sign? What do you mean? Instead of writing the words?
Under the number of moles, when you got the number of moles, there was an equal sign on the number of moles of magnesium and also nitrogen. What if only one equal sign from the left?
It is okay, but it's not as accurate as the one who has separate equal signs, because those are different computations, okay? And Martin, okay. I want to encourage you to always do the very best, okay?
Okay.
Yes. If I may still take it, someone posted in the chat, because I said, if the figure you get ends in 1.5, in 0.5, you multiply by 2. And if it ends in 0.3, we multiply by 3. So someone said, what about if it ends in the others? When something ends in 0.1 or 0.2, we just round off. Okay, if it's 2.1, it simply becomes 2. If it's 2.2, it becomes 2. In the same spirit, if it ends in 0.9 or 0.8, we simply round off, and so it will go to the next number. The challenge comes to 0.3. We have said we multiply by 3. 0.4, you multiply by 2. 0.5, you multiply by 2. 0.6, you multiply by 2. Then 0.7, you multiply by 3. Now, when you do those multiplications, they don't give you the exact figure. Like if you multiply by 0.3, you'll get something ending in 0.9. Then that is the one you round off, okay? But the most common UNEP questions I've seen, you get a 0.3 or a 0.2, right? Okay. Any other questions? This time I want people to raise their hands. We hear your voices since we are soon winding up. You raise your hand, I give you the chance to ask your question or make your comment. Yes, Claire.
Teacher, if at all magnesium hydroxide is aqueous, then what solid X?
That is part B. Was it part B or what? Sorry, I didn't follow exactly his answer, though I thought it was very okay. Oh, actually magnesium hydroxide is the solid. Okay. Yes, who is that talking, asking to be excused? Yes, Joshua. Joshua, you can talk.
Yeah, it was me, Joshua. I just wanted to add a light on what she was asking, because I saw it in the questions in the chat. So what I was saying is that normally you could know that, for example, if a substance reacts with something, it forms something aqueous. But if at all the question is specified for a solid, then you have no option but go with the solid, because if you go otherwise, then you will never do the question. But you know that magnesium hydroxide can exist in a solid state and an aqueous state. So you just have to follow the solid. So in this case, since they are telling us solid in the question, we go with magnesium hydroxide being a solid because ammonia can never be a solid. Yeah, that's it.
Yes. Thank you very much for that, Joshua. Actually, the question had a bit of a problem because magnesium hydroxide forms an alkali, forms a solution, but it is not very soluble in water. So that could make it, on the other hand, be the solid. Now, I want to emphasize this about the mock exams going around with the questions you go. If they have mistakes, that should not make you change your chemistry. Please stick to the chemistry that is in your textbooks. Do not start adjusting the chemistry because of questions that you are seeing around, okay? So Joshua, thank you very much for that comment. So we will move on. I hope Joshua has been very clear. The question said solid X, and there are only two products, ammonia and magnesium hydroxide. So in that case, we will force the magnesium hydroxide to be the solid, although we know that it can dissolve in water to form solution. So in another question, they'll call it solution X, okay? Thank you very much. Our time seems to be fast spent. We have 6 minutes. Do we have another question we can look at quickly? Emilia, do you have a question lined up for us, which you can talk of quickly? Joshua, thank you. You can stop sharing. We'll do just one more question and then we move on. Okay, and then we go to rest.
Teacher?
Yes, please.
There is a question I could go through, but someone asked, help them with the solubility of hydroxide salts.
The solubility of hydroxide salts. You just know the most soluble of the hydroxides are those of potassium and sodium. That is why those are the common alkalis. However, we also talk of calcium hydroxide because we have the lime water. Not very soluble, but we have it. So the three, actually I can say the three most common alkalis you must know, the hydroxide are calcium hydroxide, sodium hydroxide, and potassium hydroxide. Okay, now sodium hydroxide and potassium hydroxide, we even have them as solids in the laboratory. But calcium hydroxide and magnesium hydroxide, we only get them in solution. Okay, that is why we pointed out that that question had an issue. Quickly, a question from Edith, then we go to our last number. Yes, Edith.
Now, teacher, I
Yes,
was
Edith.
asking,
Mm.
but if you have 1.4 as your answer during the calculation, what do you do for that?
Okay, thank you, Edith. I thought you were listening, but anyhow, I'll repeat what I said. I said, if it ends in 0.4, 0.5, 0.6, we multiply by 2. Okay, then if it ends in 0.3 or 0.7, we multiply by 3. Is that okay?
Yes, yeah, thank you.
Emilia, okay. Emilia, do the last question and then we go. Which question is that?
Okay, so I'm going to be doing question 7.
Okay.
And for this question, you're going to need your questions with you beside you. Yes, I'll be reading my questions, but it would be favorable for you to have your questions beside you. So question 7 says, water can be transformed from one state to another through the water cycle. Part A says, name two processes involved in the water cycle. In the water cycle, we have a number of processes, and the processes I picked on this, for this number I picked on evaporation and condensation. Now we know that evaporation is when the water is leaving, for example, the lake, and going to the atmosphere, and condensation is what happens before we receive the rainfall. Then part 2 of that question says, write an equation to show how hydrogen reacts with oxygen to form water. So we have our equation there, and it has 2 moles of hydrogen, which is a gas, reacting with 1 mole of oxygen to give us 2 moles of water, which is a liquid. Then part B of this question says, drops of water were added to anhydrous copper 2 sulfate in a test tube. Set what was observed after adding 3 to 4 drops of water. Now we know that anhydrous copper 2 sulfate is a white solid. Therefore, our observation in this case is going to be that the white solid changed from white and turned into a blue solid. When anhydrous copper 2 sulfate, when you add water to anhydrous copper 2 sulfate, it becomes a blue solid. This is what we also use to confirm that a liquid is water. It's a confirmatory test for water. Then the next part of this question says, when sodium chloride crystals were placed on a petri dish and exposed for 2 days, they appeared wet. Which word describes the behavior of sodium chloride crystals? So we are having sodium chloride crystals. Sodium chloride, a good example I can give you of sodium chloride is the table salt we use at home. So this person is, let me say, placing this table salt on a plate, and they are finding that it now appears wet, but it wasn't wet earlier or anything like that. Like it was dry, it was normal. Like salt you've just got from its polythene. Yes. So they are now finding that it's appearing weight. And they're telling us to describe the behavior of the sodium chloride crystals. The behavior of these crystals is simply deliquescence. Deliquescency is when you absorb water from the atmosphere and then you dissolve in that water that you've absorbed. While hygroscopy, which I talked about earlier for concentrated sulfuric acid, is you just absorb the water from the atmosphere. These ones, they absorb the water and dissolve in it. So the last part of this question then says, name one other substance that can behave like sodium chloride when exposed. The number of substances, but here I listed 3, and those are anhydrous calcium chloride. This is the drying agent that we use in the preparation of different gases. Then we have sodium hydroxide and potassium hydroxide. That was it for number 7. Any questions?
Thank you very much, Emilia. Before questions come up, I want to mention something small we should be careful about. When you are saying describing deliquescency, you said it is when you absorb water from the atmosphere and dissolve it in it. So we are not expected to do that, but it is when a compound absorbs water from the atmosphere and dissolves in it. Be careful when we are making those definitions. Otherwise, thank you for the number. Those who are copying the answer, she emphasized that she made a mistake on the state for hydrogen. We all know it's a gas. Otherwise, the presentation is okay as it is. Thank you very much. My dears, we cannot stretch much more than this. The seminar ends at this time, but I want to make a comment. Someone has just posted in the chat asking about examinable areas. And I will say this, your teachers are teaching you with the help of what we call a syllabus. So they will teach you and emphasize what is examinable. I see you asking things like Faraday, solubility curves, and so on. If your teacher did not teach you those things, relax about them, okay? Because whoever is teaching you is teaching using a document called a syllabus. I know in the past paper questions, you'll find Faraday's, the ones of long ago, but of recent Faraday's, I'm very sure is not there. Solubility curves are not there, and so on. But your teacher will give you guidance in that area, because I did not prepare a list of what was once examinable and is no longer examinable, but I know the Faraday's are not there. Another question is to send a link to the group. Oh God, I don't have that one right now. I don't know if Mr. Kaziva is in here, but if you have a friend from your school, I don't know how we can get the link to you. Just come back for the seminar tomorrow. The link will be shared with you. Someone is asking, is deliquescency a process? Yes, a process is something which happens in stages. First, the substance absorbs the water vapor, and then it goes ahead and dissolves in the water vapor. So yes, deliquescency is a process, okay? Then what is the last question? Emilia, could you read for me the last question?
I don't know if this is the last question, but there is a question I've seen that says, is iron 3 chloride an example of a deliquescency? I think it was supposed to be
Deliquescent substance.
Yes, we use the synthesis to prepare.
I think, yes, it is. Iron 3 chloride, I think, is also deliquescent. It easily absorbs water vapor from the atmosphere and dissolves in it. That is why actually when we are preparing it, we put anhydrous calcium chloride to absorb any moisture so that it does not get to the iron 3 chloride. So yes, that is the correct one. Okay. Now, my dear students, I want to thank you very much for being active participants. I want to give a big thanks to our presenters, Dalton, Joshua, and Emilia. I want to encourage you all to continue reading so that you really master these concepts. Read your notes that your teachers have given you. I am sure they are very good, but follow certain small guidelines when you're presenting your answers. Even if the teacher gave you many answers, don't write the excess answers. Then also, don't write the excess answers, get straight to the point. Do not use formulae where they are not expected. Someone has asked what are efflorescent substances. I wish you could read, but I'll tell you just offhand. Efflorescent substances are compounds which lose their water of crystallization when exposed to the atmosphere. And they are usually hydrated salts. The most common being sodium salts. Hydrated sodium carbonate does it very easily, and it loses its water of crystallization. So it changes from colorless crystals to a white powder, okay? All this chemistry is in your books. So I encourage you as much as possible to read those books, and then you will manage. So I'm going to request someone to say a word of prayer for us, and then we close this meeting. Okay, someone willing to pray for us, could you raise your hand? Yes, Tena.
Humble ourselves and we have a word of prayer. Father, King of glory, we thank you for today. We thank you, Jesus Christ, for the lesson. Thank you, Father, for leading us through from the beginning up to the end. Oh Lord, it has been you. And Father, I pray that you continue to bless people that discussed for us, oh Lord, even the organizers, oh Lord, and for all that we shall continue to do, help us to grasp everything. In Jesus' name, I do pray and believe. Amen.
Thank you very much. Have a lovely day.